Welcome to this demo of the Ostorlab platform. Ostorlab is a mobile application vulnerability scanner that supports both Android and iOS applications. It offers static, dynamic, and backend analysis. In this video, we will cover the core features of the platform. To get started, you can create your free account or connect using Google or GitHub accounts. For enterprise users, single sign-on can be configured to allow access through your enterprise account using solutions like Active Directory or Okta. The first thing you see upon logging in is the dashboard, which displays over 100 metrics indicating the health of your organization. It shows the distribution of scans, vulnerabilities by risk, and other vital information, like when scans are conducted and what the most common vulnerabilities are. The second dashboard tab focuses on remediation. One of the platform's key features is tracking fixes over time. It provides visibility into how many issues are open, being addressed, accepted, or reopened. Each vulnerability is tracked using a DNA computed based on its attributes. Vulnerabilities are tracked in a single ticket. This is particularly critical when you integrate with platforms like Jira, ensuring you won't be spammed with new tickets every time you run a scan. To trigger a scan, you can use the button on the dashboard or the left menu by going to Scanning and then selecting New Scan. For store applications, select the store and application by name. You can also search the application by package name or bundle ID. Then choose the type of assessment, either fast, full, or privacy scan. Fast scans are ideal for CI/CD integration, while full scans are more exhaustive and recommended before release. Fast scans perform configuration checks, check for outdated dependencies, and identify insecure coding patterns using taint analysis. Full scans conduct dynamic analysis, intercept traffic, and fuzz for backend vulnerabilities. Privacy scan focuses on privacy issues and checks the application behavior against the application's privacy policy. For dynamic analysis, you can provide various credentials such as username and password, custom credentials, or other information like shipping address, credit card, or email. For complex workflows, such as 2FA, scripts can be added. Scripts can be tailored to any use case you have in mind. To go over it again, running a scan is very simple. Select the app, select the type of assessment, and hit Submit. It's that simple. For unreleased apps, you can upload the app file, whether it be an APK, Android bundle, or IPA. You can optionally add a lock file or SBOM file for more accurate dependency identification. The rest of the steps are the same. A fast scan typically takes about 20 minutes, while a full scan takes around 3 hours. When entering a scan, the first thing you will see is a scan summary. The scan summary contains information about the application and the scan. In addition to how many findings were reported, you can see which permissions the application has, which activities, services, and URL schemes the application is exposing. You can even access the list of backends the application is communicating with, including their IP and geographical location. This is particularly helpful if you need to ensure compliance with data location regulations. While the scan is running, you can already access the scan report. In the scan report, you will find a list of findings with risk ratings from critical to low. Some findings are marked as potential, indicating unconfirmed findings that are either contextual or have a risk of false positives. Some findings are marked as hardening, which are not vulnerabilities, but mitigations for some vulnerability classes, like SSL pinning or checks for rooted devices. Each vulnerability has contextual tags, such as security issue, privacy issue, public exploit, or under active exploitation to help prioritize important findings during remediation. The platform detects various vulnerabilities such as configuration issues, hard-coded secrets, insecure dependencies, known CVEs on the backend, insecure communication, and insecure TLS validation. It also fuzzes for vulnerabilities from SQL injection, command injection, to template injection and cross-site scripting. In total, over 600 vulnerability classes are covered, and over 100,000 dependencies are detected. In the vulnerability report, you will find detailed information about the finding. There is a recommendation section that provides detailed steps to address the issue. You will also find a technical details section where you can access the proof of the vulnerability, such as stack traces, configuration parameters, or network traffic evidence. In addition to this section, if you have the AI engine enabled, prioritization of findings is added to each scan. The AI engine generates precise remediation recommendations, providing step-by-step instructions for fixing vulnerabilities, which is especially useful for complex issues. The findings can be accessed from the UI, but can also be downloaded in different formats, like PDF, CSV, and zip. Different PDFs are accessible, like executive summaries, full reports, and standards reports. An executive summary provides an overview of the findings without any technical details. The platform supports various standards such as OWASP Mobile, PCI, SOC2, and privacy standards like GDPR and CCPA. You can generate standard reports, executive summaries, or full reports for compliance. Now that we have gone through the report, a common question we receive is how to compare scans. The platform doesn't provide a direct feature to compare scans because it manages this for you. Each vulnerability is assigned a ticket, which can be synced with Jira or other ticketing systems. The platform ensures continuity by managing tickets across scans. You can customize ticket settings, assign people, set resolution times, and mark issues as exceptions or false positives. Now that we have seen how to start a single scan, this can quickly become tedious. Ostorlab supports the configuration of monitoring rules. Rules can either be continuous or cron-based. In continuous mode, it checks for new releases of the app on the store and triggers a scan. In cron mode, you can schedule scans to run at specific times, such as the first Monday of the month or every Friday. In addition to monitoring, Ostorlab supports CI/CD integrations with Jenkins, GitHub Actions, GitLab, Azure DevOps, and all popular mobile CI/CD platforms. You can configure parameters, risk thresholds, and scan durations. Large teams and enterprises can also benefit from single sign-on integration with SAML, such as Azure Active Directory, Okta, etc. The final thing I would like to present is the analysis environment. The analysis environment is one of Ostorlab's unique and most advanced features. It allows you to access file content. You can click on the DEX file and access decompiled source code, or click on a native library and access decompiled C code. You can view dynamic call coverage results and access device logs. You can even download PKIP files with network traffic and navigate call stacks collected during dynamic analysis. It is extremely useful to have a common platform to discuss issues with different teams like development and security, simply by sharing your screen. This was a quick overview of the core capabilities of the Ostorlab platform. Future videos will delve into more advanced features. Thank you for watching.